You look up at the night sky, and it seems still, peaceful. But the truth is, every galaxy, every star, every atom is being pushed apart by something we cannot see. They call it dark energy, and it may decide the fate of our entire universe. But what exactly is it, and where is it taking us? Chapter 1. The Illusion of Stillness. Look up at the night sky. What do you see? A sea of stars, quiet and unmoving. For thousands of years, humans believed the universe was still fixed in place, like a painting stretched across the heavens. The stars didn't seem to change. The constellations returned each season. The moon followed its pattern, and the planets danced slowly across the sky. Everything felt ... eternal. Even as we learned that Earth spins and orbits the sun, we still held on to the idea that the larger cosmos was static. The heavens were a backdrop, not a moving part of the story. It wasn't until the 20th century that this illusion finally broke. In 1929, something changed. An astronomer named Edwin Hubble made a discovery that shook the foundations of astronomy and our understanding of reality. He had been studying the light from distant galaxies. Using powerful telescopes, he could see that their light was stretched, shifted toward the red end of the spectrum. This redshift meant one thing: the galaxies were moving away from us. All of them, and not just drifting slowly. The farther a galaxy was, the faster it was fleeing. It wasn't just motion, it was expansion. The universe itself was growing, stretching in every direction, like the surface of an inflating balloon. This discovery marked the beginning of a new era. The universe was not static, it was dynamic, alive, in motion. What we thought was stillness was actually a grand illusion. But why was it expanding? What force was behind it? Gravity, the glue of the cosmos, should have been slowing everything down. After all, every galaxy pulls on every other galaxy. Over billions of years, this pull should have been enough to at least reduce the speed of expansion, maybe even reverse it. That's what many scientists believed. But once again, the universe had other plans. In the late 1990s, two teams of astronomers, one led by Saul, the other by Brian Schmidt and Adam Rees, set out to measure how fast the universe was expanding in the past. They studied supernova, the exploding deaths of massive stars, as cosmic markers. These explosions are so bright they can be seen from across the universe. By comparing their brightness and distance, scientists could figure out how fast galaxies were moving billions of years ago. What they found was shocking. Instead of slowing down, the universe was speeding up. The expansion was accelerating. Somehow, galaxies were being pushed apart faster and faster as time went on. A mysterious force was driving them away from each other, fighting against gravity and winning. That force became known as dark energy. It wasn't what anyone expected. No one saw it coming. It had no color, no shape, no clear presence. Yet its effects were everywhere, written across the skies. The illusion of stillness was gone forever. And yet, even today, most of us still feel like the stars are standing still. We look up and see patterns, not motion. The Big Dipper hasn't changed. Orion still rises each winter. It's comforting, familiar. But that calm night sky is a mask. Behind it, space itself is stretching. Galaxies are drifting. Some are colliding. Others are fading into the distance, moving so fast they will one day slip beyond the edge of visibility. The truth is, we live in a restless universe, and the Milky Way, our galaxy, is part of this story. We are not anchored. We are not at the center. We are on a moving island, caught in the current of something vast and unseen. The stars around us are in orbit. The galaxy itself is spinning, and beyond that, it's flying through space at hundreds of kilometers per second, along with other galaxies in our local group. But even that motion is just a layer. Zoom out far enough, and we are all drifting in a great tide, one that dark energy seems to be controlling. For centuries, we thought the universe was permanent, unchanging, but now we know. Everything is in motion. Everything is part of a greater flow. The question is, where is that flow taking us? That's what we'll explore in the chapters ahead. We'll follow the path of dark energy, trace the fate of galaxies, and ask what will happen to our home, the Milky Way, in the far future. But it all starts with letting go of an illusion, the stillness we thought we saw. Because in the grand story of the cosmos, motion is not the exception, it's the rule. Chapter 2: The Force with No Face. What is dark energy? When something moves, we look for a cause. If a tree sways, we blame the wind. If a planet shifts, we point to gravity. Every motion has a reason. But what if the reason can't be seen, can't be touched or measured directly? What if the entire universe is being pushed by something invisible? That's where dark energy enters the story. We've known for over a century that the universe is expanding. That much was expected. But the shock came in 1998, when astronomers discovered the expansion was not slowing down, was speeding up. Something was working against gravity, pulling galaxies apart faster and faster as time passed. Whatever that something was, it had to be powerful. Very powerful. Scientists gave it a name: dark energy. It's a strange name. Dark doesn't mean evil, it means unknown. And energy is just a placeholder. We still don't fully understand what this force is. All we know is that it exists. It must exist, or the math doesn't work. The universe is accelerating. Galaxies are racing away. Something is behind it. And that something makes up about 68% of everything. Think about that. Most of the universe isn't stars or planets or even dark matter. It's dark energy. Invisible, untouchable, yet absolutely dominant. To put it in perspective, ordinary matter, the kind you, I, and every star is made of, makes up about 5%. Dark matter, which we also can't see but can measure indirectly, is about 27%, and the remaining 68%, dark energy. It's everywhere, in every direction. Even the space between atoms is filled with it. It doesn't clump or gather like matter. It doesn't emit light, but it shapes the entire structure of the cosmos. By pushing, gravity pulls things together. Dark energy does the opposite. It drives things apart. The more space there is, the more dark energy there seems to be. It's like a pressure that builds as the universe grows. But where does it come from? There are a few theories. The simplest one goes back to Albert Einstein. In 1917, he introduced something called the cosmological constant. At the time, he believed the universe was static, so he added a factor into his equations to prevent it from collapsing due to gravity. Later, when Hubble showed that the universe was expanding, Einstein called the constant his biggest blunder. But maybe it wasn't a mistake after all. Today, some scientists believe the cosmological constant might explain dark energy. In this view, dark energy is simply a property of space itself. As more space appears, more energy appears with it, pushing everything farther apart. Another idea is quintessence, a dynamic form of energy that changes over time, unlike the constant. If this is true, dark energy might weaken or grow stronger as the universe evolves. There's also the possibility that it's tied to the vacuum energy of space. Quantum physics tells us that even empty space isn't truly empty. Tiny particles flicker in and out of existence. These quantum fluctuations may be producing a force that acts like dark energy. Each theory fits part of the puzzle. None of them fit at all. So how do we even know dark energy is real? We see its fingerprints. We see galaxies moving away at accelerating speeds. We measure the light from distant supernova, tiny explosions that act like cosmic mile markers. We map the cosmic microwave background, the ancient radiation left over from the Big Bang, and see tiny imbalances that only make sense if something like dark energy is present. We build simulations of the universe, plugging in all the known forces and rules. Without dark energy, the models fall apart. With it, they align with what we observe. So while we may not know what dark energy is, we're certain it's there. It is not the first time in science that we've named something we can see. We did it with gravity. We did it with atoms, long before we could observe them. Naming it is our way of holding on to the mystery, of admitting we don't know, but refusing to turn away. Still, There's something unsettling about dark energy. It doesn't act like anything we've seen before. It doesn't follow familiar rules, and its effects are growing. As the universe expands, dark energy doesn't thin out, it keeps working. The more the universe stretches, the stronger its influence becomes. That's different from gravity, which weakens with distance. It means that over time, dark energy becomes the dominant force. Eventually, it could overpower everything. Some scientists fear this could lead to a Big Ripper future where dark energy tears galaxies apart, then solar systems, then atoms themselves. It's only a theory, but one that reminds us how little control we have in the face of cosmic forces. Others suggest a gentler future, one where galaxies drift so far apart that the night sky goes dark not from disaster, but from distance. A quiet, cold universe. For now, we live in a unique moment. We can still see other galaxies. We can still study their light. In the far future, that might not be possible. Civilizations that come after us may never know the universe was once so full of stars. They'll look into the sky and see nothing, only darkness. That's why understanding dark energy matters. It's not just about physics, it's about time, about knowing where we are in the story and how much of the book is left. Dark energy is the force with no face, a pressure without a source. It doesn't roar, it doesn't burn, but it moves everything. And the Milky Way, it's not just drifting, it's being carried. Chapter 3. The Cosmic Consequences. A universe that won't stop growing. Imagine dropping a ball and watching it fall faster and faster. Gravity pulls it. That makes sense. Now imagine letting go of the ball, and it floats away, gaining speed over time. That's what's happening to the universe. We expected gravity to slow things down, to pull galaxies closer, but instead, the opposite is true. The galaxies are flying apart, and the distance between them is growing not just steadily, but at an accelerating rate. Dark energy is making it happen, and the consequences are bigger than most of us realize. Let's start small. Our solar system is safe for now. The planets are held tightly by the sun's gravity. Even the stars in the Milky Way stay bound together. Local forces are stronger than the push of dark energy at that scale. But zoom out, and everything changes. Our galaxy, along with a few dozen neighbors like Andromeda and the Magellanic Clouds, forms what we call the local group. These galaxies are gravitationally linked, like dancers spinning in the same circle. But beyond that group, space is stretching. The Virgo cluster, a massive group of galaxies relatively near us, is already moving away. So is everything else in the larger Laniakea supercluster, the region of the universe we're part of. All these galaxies are drifting outward, like pieces of driftwood caught in a rising tide, and the tide is getting stronger. The more space appears, the more dark energy fills it, and the more dark energy fills it, the more space stretches. It's a self-feeding cycle, one that doesn't slow down, it speeds up. Here's what that means for the far future. Right now, when we look into the night sky, we see galaxies millions and billions of light years away. Their light reaches us after traveling for unimaginable spans of time. We study that light. We learn about the past. We chart the universe, but that light has a limit. Galaxies that are far enough away are moving faster than light itself, not because they break the speed of light, but because space itself is expanding between us and them. Their light can never reach us. It is like they're standing still on a rubber band that is stretching faster than they can run. In time, even galaxies that we can see today will slip beyond that limit. Their light will stretch until it's too faint, too red, too slow to ever reach us. They'll vanish not in explosions, but in silence. This is called cosmic isolation. One day, far in the future, the only galaxies visible from Earth will be the ones in our local group. Everything else will be gone from view. It will seem as if the universe contains only a few galaxies floating in endless darkness. That's not science fiction. That's where the physics is pointing, to a lonely universe. This has deep consequences not just for astronomy, but for knowledge itself. Imagine a civilization living trillions of years from now. They study the sky, just like we do, but they see no galaxies beyond their own, no cosmic microwave background, no clues to an expanding universe. They might believe the universe is small, static, just as we once did. All the evidence will be gone, stretched beyond detection by dark energy. We are living in a special time, a time when the universe is still visible, still readable, but this window is closing. And the irony is, it's closing because the universe is growing. Now, you might ask, what's the end game? Will this just go on forever? Maybe. In one scenario, dark energy continues to act as a constant force. The universe keeps expanding, but galaxies stay intact. Over time, star formation slows, gas is used up, the stars die out, and the universe enters a cold, dark age. This is called the heat death, or the big freezer future, where everything fades. In another, more extreme version, dark energy grows stronger. It becomes more than a steady push, it becomes a pull-apart force. In this case, galaxies are torn apart, solar systems unravel, planets drift from their stars, eventually, even atoms are ripped apart. This is the Big Ripper, dramatic end to everything, caused by the ultimate expansion. There's also a third possibility. Maybe dark energy is not forever. Maybe it weakens over time. If that happens, gravity could regain control. The universe might slow down, stop expanding, and collapse back in on itself in a big crunch. That would be a kind of reset, a reversal of everything we know. But so far, all signs point to continued acceleration. That means the most likely outcome is eternal expansion. So what does that mean for us today? In a way, it makes everything more precious. The stars we see now, the galaxies we study, they won't always be visible. We are part of a narrow chapter in the universe's story, a time when the cosmos is large, bright, and open. One day, the universe may still exist, but it will feel ... empty, a quiet sea of darkness. This is the cost of dark energy. Not destruction, not chaos, but separation. It doesn't burn or crash. It doesn't announce itself. It just pulls, silently, relentlessly, and it changes the shape of everything. We like to think of the universe as eternal, but it has a direction, a flow, a timeline, and we're in the middle of it. So the next time you look up at the stars, remember this. Most of what you see is already on its way out, fading, not because it is dying, but because it's being carried beyond our reach. That's the consequence of a universe that won't stop growing. Chapter 4, Milky Way's future, collision or escape. In a universe that's always expanding, it might seem strange to hear that something is coming closer, but that's exactly what's happening between us and our nearest galactic neighbor. While dark energy pushes distant galaxies farther apart, local gravity still holds sway in our corner of the cosmos, and within that local zone, two giants are on a slow-motion collision course. The Milky Way and the Andromeda Galaxy are both massive spirals, each containing hundreds of billions of stars, and despite the grand expansion of space, they're moving toward each other at about 110 kilometers per second. Not tomorrow, not next century, but in about 4 billion years. The future of our galaxy is a dance, one written in the stars long before life appeared on Earth. So what will happen when these two giants meet? Let's start with the basics. Galaxies collide more often than you might think. The universe is vast, yes, but over billions of years, gravitational interactions make these events almost inevitable. And while the word collision might sound violent, most stars are so far apart that they'll pass by each other unharmed. What we call a collision is more like a merging of star systems, two swarms passing through, reshaping each other in the process. When Andromeda and the Milky Way finally collide, their stars will mix, their shapes will distort. Long tails of gas and stars will stretch out like ribbons, curved by gravity. Over time, the two spirals will settle into a new form, likely a large, smooth elliptical galaxy. Astronomers even have a name for this future structure, the night sky. if seen from Earth in those days, will be unrecognizable. Andromeda will grow larger each million years, eventually dominating the view. During the merger, great arcs of stars will paint the heavens. Some may brighten with bursts of star formation, others may fade as gas clouds are torn apart. And what about us? Our solar system will almost certainly survive. The chances of a direct star-to-star collision are incredibly low, but our position within the galaxy may shift. Right now, we orbit about 27,000 light-years from the Milky Way's center. After the merger, we could find ourselves flung to a different orbitor, even ejected farther out into the galactic halo. But here's the strange twist. This merger, this moment of galactic transformation, will happen in a universe that is otherwise growing cold and dark. While Milkomeda forms, most of the other galaxies we see today will have already vanished from view. The cosmic expansion will have pulled them too far away. Their light will no longer reach us. Milkomeda may be one of the last visible islands in a vast, black ocean. And after the merger, after the dust settles, Milkomeda will remain, bound by its own gravity, alone. That's the fate dark energy leaves us with. It doesn't just separate galaxies, it isolates the survivors. It turns clusters into archipelagos, and archipelagos into single drifting worlds. But this future isn't just empty, it's also quiet, predictable, peaceful, in a way. Inside Milkomeda, stars will continue to orbit. Some will form, others will die. White dwarfs, neutron stars, and black holes will populate the galactic core. Life, if it still exists, will look out and see nothing beyond their own galaxy. No signs of a universe ever filled with light, just milk and the darkness beyond. From a cosmic perspective, it's a kind of retirement, a graceful winding down of stellar drama. Still, there's a question that lingers. Is this truly the end of motion? Will the Milky Way and everything within it settle permanently into this slow orbit around nothing? Or will dark energy continue to grow and unbind even this last structure? We don't know. Some models suggest dark energy will remain constant. In that case, Milkomeda survives, a glowing ember in the void. But if dark energy increases, if it is not a cosmological constant but something dynamic, then even Milkomeda could unravel. First, the stars might be pulled from their orbits, then solar systems, then the planets from their stars. In the final stages, dark energy could even overpower atomic forces, tearing matter itself apart. That's the Big Rip scenario. Again, this is only one possibility. Most scientists believe that galaxies like Milkomeda will remain stable, but when dealing with something we don't fully understand, certainty is a luxury we don't have. What we can say is this: the Milky Way's days as a spiral galaxy are numbered. The merger with Andromeda is not a maybe, it's a when. We're on a set path, and it's strange, isn't it? We think of our galaxy as permanent. We name it in myths. We photograph it in the night sky. We imagine ourselves as children of the Milky Way. But even galaxies are not forever. They grow, they drift, they collide, they change, and they do so on timescales that make our lives seem like a breath. So where does that leave us? It leaves us in the middle of something beautiful, a chapter in a story too big to finish, a moment inside a galaxy that is moving toward its own transformation. We may never see the merger. Earth might not even survive that long. But just knowing it's coming gives us perspective. We are part of a living universe, or universe in motion. And in that motion, there's wonder, there's meaning, and perhaps a little peace. Chapter 5: The Questions That Outlive Us. There is something haunting about knowing how the story might end. We've traced the path of the universe from its expansion, to the hidden hand of dark energy, to the slow unraveling of what we once thought eternal. The Milky Way will merge. The galaxies will vanish, space will stretch, and one day, there may be no stars left to see. But here's the truth. We still don't know why. We know the universe is expanding. We know dark energy is driving it, but we don't know what dark energy truly is. We've named it, yes, we've measured its effects, but it remains a mystery at the center of everything. It doesn't glow. It doesn't react. It doesn't gather into clouds or collapse into stars. And yet, it moves the cosmos. So what is it? Some theories point to the structure of space itself, that perhaps, even in a perfect vacuum, the universe contains a background hum of energy, a kind of invisible pressure built into the very fabric of reality. Others imagine dark energy as a dynamic field, changing over time, influencing gravity in ways we can't yet see. There are even ideas that dark energy could be a sign of something more radical. Maybe it isn't a force at all, but a clue that our understanding of gravity is incomplete. Maybe the universe is stranger than we can imagine, not just in its matter, but in the laws that govern it. And maybe, we'll never know. The truth is, our tools are limited. We observe from one point in space during one brief slice of time. We see light that's taken billions of years to reach us, filtered through dust, distorted by distance, weakened by time. We build theories from that light. We build meaning from what we can measure. But the universe is not obligated to make sense. It just is. Still, that doesn't stop us from asking. In fact, it makes the questions more powerful, because long after the stars burn out, long after the galaxies fade, the questions may still remain. Where did we come from? What is dark energy? Why is there something rather than nothing? What lies beyond the edge of space, or before the beginning of time? These are questions that outlive our lifetimes. They pass from generation to generation, not because we're certain they'll be answered, but because they matter, even if they aren't. They remind us that we are more than observers. We are participants in a story that spans billions of years, a species that looks up and asks not just what is out there, but why it's there at all. In a universe filled with silence, we are the ones who speak, and that matters. Even if dark energy remains forever nameless, even if the stars go dark, even if, in the farthest future, there's no one left to remember the sky, the questions once asked will have shaped how we lived, how we explored, how we imagined our place in the vastness. So maybe the legacy of our time is not what we built, but what we wondered. Maybe it's not about reaching the end of the story, but about being willing to begin it in the first place. As we've seen, dark energy is a force with no face, a quiet drift spreading the galaxies apart. But in the spaces between those galaxies, we've found thought, consciousness, curiosity, ourselves, and that might be the greatest mystery of all, that out of all the cold and empty darkness came us. So here we are, on a pale blue planet, inside a spiral galaxy, drifting toward a collision that will reshape everything, and beyond that into a future we cannot fully predict. But we are still here, still asking, still wondering where the Milky Way will go, and what will happen next. If this journey left you wondering, you're not alone. We make videos for the curious, for those who look up and feel something deeper stirring. If that's you, consider subscribing or sharing this with someone who asks the same kind of questions, and leave us a comment. What do you think dark energy really is, and where do you believe the universe is going? Until next time, keep looking up. The sky is still speaking.